is probably the most exciting thing that Corey and I are going to do this morning as developers. We love to show off new products, to get feedback. It's also a very nerve-wracking experience because being on the R&D team never really done, right? And you're always like, oh, there's so much more I can do. And you probably noticed yesterday that Corey and I were absent. We were in the next room over there trying to put more and more in it to give you guys more value in this portion of the presentation. As Bruce mentioned, Corey and I were kind of split off from the Crescent team to focus on research and development. How can we modernize Crescent Link? How can we not only understand utility network, which we talked about in the last presentation, but if we were going to develop our own data model, what would it look like, and how would it satisfy the needs of our users? And so we developed this team called Brightwire. That's basically Bruce. He came up with that name. Kind of catchy name. So what we're going to show to you today is what we've been working on as a hedge is the utility network. I'm Jason, this is Corey. The agenda today, we're going to talk about why the team was formed. One of the other things that we do aside from creating this data model is we have a tool out there on the ArcGIS marketplace for generating 477 broadband reports. I don't know how many of you deal with that with the FCC, but we do have a tool out there that can help kind of speed that up. So we're going to do a quick public service announcement, a demonstration of that. And then we'll get into the model and review that, and then do a Q&A. Yeah, you know who these people are. Sometimes I don't know who they are. I'd be remiss to say it was just Corey and myself. Bruce was a big part of this. We had many sessions on the whiteboard with Bruce, pulling his telco experience, getting all our telco experience, and talking about different scenarios. We also had two other members, Natalie and Carson. They were with us at the start of the year. Natalie been with us for a number of years. They moved on to their own private ventures. Both of them went into business for themselves, doing things that they love, so I'm really proud of that. They were an important part of the user experience piece of this, as well as Corey and I kind of working on the back end. So our goals, when we put the Brightwire team together, these are the things that we were kind of hearing from you guys as users. We wanted to enable mobility. Probably the number one request we get when we're either demoing to a prospect or talking to our customers and say, how can we get this in the field? In order to get it in the field means we got to get it off of desktop, and we've got to get it functional across a wide range of platforms. So whether it's your phone, your tablet, whether it's an Android phone or an iPhone. So you have the native apps, web apps, right? So you probably don't want this heavy client or somebody in customer service who just needs to do a simple trace. So looking at web client, we knew we wanted to migrate to Pro. We talked about this in the last segment. It was one of the questions was, Pro has some good functionality for developers and for users. The ability to go from 32-bit to 64-bit game-changer. Having multi-threads is a big deal. So we had this desire to migrate to Pro. We wanted to modernize the user experience. If we're honest, when you're in our desktop, it feels like you're in an application that's a bit old. Right? It's not like the applications you use today that are on your phone. And it was also a purview for our team to strengthen this relationship with Ezra. We talked a lot about that in the last presentation. And the reason that's important to you, or we believe it's important to you, is we want to move that truth closer to the field. We want to empower the field technician, the splicer, the inspector to be able to do stuff on their phone. And I know when I got into this, when I got into GIS as part of a telco company in Alaska, there was a lot of, I don't want, it'll break. If I take a tablet out to the field, it'll break. And that was true, right? Those early tablets were the field. I don't know how many times I heard, yeah, I'm just going to bury it the first hole I dig. Right? I'm just going to bury it. That was just a part of the thinking, 5, 7, 8 years ago. That was kind of the thing. But today, I'm seeing more and more people using these apps to do their work. I spoke to the folks from North Georgia, and they were telling us how they modernized their approach and doing everything on that tablet when they go out to the field. They do their staking, they do inspections, they create their assets. That's exciting to us because this new platform. We knew we needed to get off of desktop. You probably heard yesterday that this is a deprecated product for Esri. It kind of changes every year though. Seems like they keep adding another year. But eventually desktop's going to go away. So as a developer, we've got to move to the flagship. We got to keep pace with our partner. We want to increase your productivity. I'll tell you. As we talk about utility network, 27 clicks to connect two strands, that is the opposite direction that we want to go. We want to look at how long things are taking in Crescent Link or in the tools that you're using and try to make them faster, reduce the number of clicks, increase the performance, give you better response times, things like that. So that's important. And ultimately, we want to stay ahead of the game so that we continue to be a trusted relationship. We talked about that a lot in the last portion of the presentation. Okay, so 4.7s, for those that don't know. Actually, raise a hand, how many people deal with 477 broadband recording? Okay, more than expected. In my prior, one of my duties in my prior jobs that coming on working with Bruce was getting the teams together to do the 477 report twice a year. That includes getting the marketing team, getting the engineering team, getting the legal team, everybody together to say, what do we need to do, how do we need to do it? And it was always a slog. It took 3 months to do a report every 6 months. And so, over that process, I developed this kind of understanding of what was needed for the 4.7's report, what it needed to look like. We pseudo-automated it at Alaska Communications. And I remember the first time we had the CSV file generated, not by hand, but by a system, and I handed it to legal to upload it, and they were like, right? And they uploaded it and it worked. It accepted and everything was good. And they're like, huh, all right, that was easy. So I brought this idea to the team and said, hey, let's develop a pro add-in. The benefit to this is we're going to give you guys the ability to generate this report quickly. So you have the format all ready to go. You can upload it. But it also gives us as developers a chance to use Pro, use the SDK before we try to forklift Crescent over to it. So about 2 years ago, we came up with this. We published it. We told Esri about it. They got pretty excited. We published it on the RJS Marketplace. We'll show you that in a minute. But as an add-on, it's meant to speed up the 477 reporting process. Now, this doesn't do your broadband qualifications, so I want to set that ground level now. You've got to have qualified data in your map before you can use this. But what it does do is it takes that information and run you through a wizard, and it outputs the CSV file that you would expect to upload. You should have no problems turning that into the FCC. It does adhere to the FCC's reporting format. We do try to stay up to date with the changes that come out. Usually annually there's some adjustments, whether they add new codes or they change what needs to be reported. There are several reports. This is strictly the broadband report. Let's keep that in mind. So this isn't a wireless report. This is what it kind of looks like. We're going to do a quick demo. So Corey's going to pull it up for us. Okay, so what you're looking at here, this is Pro. What we have on the map here are polygons representing the different census blocks. This is Pickens County, which is a county just south of us. More specifically, it is around the Clemson area. That's where our home office is. These points represent service locations or endpoints, address points. As Corey opened this up, we can see that on the service locations, we've got a lot of information, a lot of attribute information that describe what technology it is, max up and down speeds, all of this. So ultimately, we'll take in these two feature classes or feature services, whatever we've got, and output a report that you can upload. Fundamentally, let's look at this census block, look for the max up and down for residential and commercial, output the line for the CSV file, and move on to the next census block. So Corey's going to describe to you what you're seeing here.
So this is the add-in manager. Basically, this is what you'll see after you install the add-in. This is really just a way to come in and manage your add-ins if you have another one for a later demo. Just, there's a little bit of information here about it. So I'm going to open the wizard from our geograph tab. You just click on this button and it comes up. As Jason said, for right now, we just have the broadband report. Select that. You can enter your provider name.
For those of you who know, this is your doing business as name that you put on your report. It has to be on every line in the CSV. So you enter that in.
So now we're going to select the layer with the census blocks. We're going to specify the layer that has the block ID in it. It has to be 15 characters. So this is for our service locations layer. We select that here. And then we want to select the attribute in the table that represents the type of service location that it is. And all this is a mapping tool. Let me say for consumer, this is the field value that I want to use. For business government, this is the one I want to use. Next. So now we're selecting the technology type. Same deal here. So we've got our different field values. This is what's in the table. It's automatically pulled in. And these are where you can map them. So just go through each one. Specify which one it goes to. Yours might look a little different. It can really be however you want to put it in your table.
Yeah, I'm going to pause it right here. This looks, oh yeah, 40 goes to 40. That makes sense.
Right.
In my previous job, as I mentioned, at Alaska Communications, we had to pull in information from all of these different parts of the organization. And they didn't have these nice, pretty codes to line up, right? They may call it this, or they may call it that. So part of this wizard, what allows you to do is you don't really have to have perfectly clean data in terms of what it's called. You just need to know that this field carries my technology. It doesn't have to be called technology. You can say, I want to map the technology output to this field, and we might call it service or product or whatever it is that you have in your data. So that's the purpose of stepping through this wizard. It allows you to kind of connect dots.
A question is, sometimes I see a lot of customers' data models, they have like hand-typed values, and sometimes they might misspell or type it out. Can you map multiple values
You can.
to that field?
Yeah, good question.
I can select any number of these. You can see it populates on the left which one they're mapping to.
Thanks, Tim, for remembering to point that out. Nice little in there.
Yeah, so if there was a typo or something like that, if you had the name in here instead of the key value, you could see that it was the right one. You can map to both.
Good point. Thanks, Tim.
Okay, so now I'm just going to select the max advertised downstream field. And then the upstream.
Obviously, we made them easy to be able to select.
Right. And there used to be the contractual values. That was what they removed about a year ago, I believe. So we took that out of the tool. And now we're just going to select specify a file output.
So, 5,000 locations, done like that. Report's ready to go. 3 months to 3 seconds. Anyway, you'll pull up the file so that you can see that it is in the correct format, CSV. So it's comma delimited. This is the census block ID. You're doing business as your technology, and then your flags for whether or not there's residential or commercial in there, and if there are, what are the speeds, and what are the maximum speeds in that location. So it really does, it is pretty helpful, we think, in terms of just making life a little easier when you're trying to do that fixed broadband. Any questions about this? You might be asking, where do I get it? Oh, you're looking at that. It's free, doesn't cost anything. Go to the ArcGIS Marketplace. Here's the listing, it's 4 sevens. You can simply type that in when you go to the Marketplace to search. You do need to have your ArcGIS portal or admin administrator give you access to download listings. Okay, you might go here, you're signed in with your username, but you can't download it. It's because your ArcGIS administrator needs to allow you to download add-ins. Because what this will do is it'll put it in their portal and then make it available for you to add into your profile. And that's what you can do. So there was some confusion around that. Any questions? Okay. Anybody do any other reports besides the fixed broadband report? Yeah, it's pretty common for most wireline providers. Okay. Let's move on. All right. And for the heavyweight round of the morning, Brightwire. So we set out to, probably about a year and a half ago, we started tinkering and looking at technologies on how we could modernize the data model. What in Crescent Link is called the stable data model. At the time, we were trying to figure out what can we do to the data model to give us better performance. And we tinkered with a lot of different technologies on the database side, on the programming application side. We looked at React and JavaScript as a front end. We looked at relational databases and non-relational databases. We looked at how to deploy these in the cloud. So we ended up exploring a lot of different technologies. It really wasn't until we did the work with the UN and explored it that we started to say, hey, wait a minute, maybe we've got something in this other data model that we need to put a little bit more time into. So as we kind of brought all that information together, we decided that early on it needed to be a relational model. It needed to be in a relational database so it could live inside the geodatabase, right? Whatever we were going to do, we wanted to stick with Esri, and we wanted to keep the model as close to Esri's geodatabase as possible. Now we certainly could have gone off and built our own database and then tried to build relationships between stuff in that database and an Esri geodatabase. Trying to manage a relationship between two databases is pretty tricky, and it's not something that's fun to do for the DBAs. So we said, you know what? Let's just simplify this. The constraint we're going to say is whatever we build has got to work inside a file geodatabase or an enterprise geodatabase. So we kind of set that. That took a whole slate of technologies off the table for us. We really were interested in this NoSQL or what's called like a document database. This is how all your search engines, how Facebook, that's how they manage their networks, is with these non-relational databases. And it would have been a real boon for us. Unfortunately, there's no GIS technology that works in those types of databases yet. It's another thing we kind of put these bugs in Ezra's ear to say, hey, think about this. If you really want to get performance, move this direction. But in the end, we decided to go with a relational database. We knew we wanted it to be accessible from various clients. And when I say clients, as I talked about, the phone, tablet, web interface, desktop pro for desktop or pro for the power users. And in the old days, the way it used to be was if you were building for desktop, you interface with the desktop SDK, and you built this whole stack of an application to work there. If you were building for a native app, you built a whole stack for there. As web has kind of taken over and HTTP has become the communication method, you've seen this emergence of APIs. They allow you to interface from any type of client to the back-end functions of the things that you do. If you want to perform a trace, you don't have to perform trace for each application. You build an application interface and you ask it to do the trace. So basically the server, the back-end is doing this, which fits nicely with having various technologies, because on the back end you only have to build it once. You want to build a data model and the API, and then you can let any type of client interact with it as long as it's relatively standard. So we settled on kind of a REST API endpoint technology that allows, which is the most common out there right now, and that's what we're using with the Brightwire data. We also knew that speed of execution or speed of operations was key to the user experience. I don't know how many times early on in Crescent Link I did a trace and like, okay, I'll go get a cup of coffee. Oh, it's almost there, right? Especially on large count cables, which is understandable, right, given the data model that's behind it. UN was gonna make it even worse. But we knew that the user experience was key, and it all started with response times and performance, so we're gonna talk a little bit about that. We also knew, based on our UN experience, that we needed to keep it simple. Yeah, we need to keep it simple. And so we set out to do that. We want to get very, we want to strip away all the clutter and get down to the core of what's important. And so there's lots of different functions you can think about from the user perspective, but one of the heavy lifts that we typically see is the trace performance, because you're looking at so much information and trying to pull out the information that's important to that trace. So we use that as our linchpin for this model. We knew if we could get trace, any type of trace going quickly, and other things like search, other things like just interacting with the data model would be much easier. So this was the heavy lift, and that's where we focused our attention. So this is not the Brightwire data model, but what you're looking at here is what we kind of mapped on a whiteboard as a trace model for a typical FDH. And what you see here are nodes that are connected. The connected lines represent the relationship. The colors represent the feature. So if you see red, that could be, these are nodes that could exist in one point feature. See blue, that is a node that could exist in a line feature. I say exist in, what I'm really saying is related to a line feature, right? The model on the back end says this is a node, but when you're looking at it on the map, this is a line, right? That's what it represents here. But we set out to say the typical feeder, the physical connection of a strand, you're going to start at an OLT port, right? You come off that OLT port, go to the SFP. How many people are modeling SFPs on the network right now? Okay, good. I'm happy to see someone is, right? But SFP has two sides. It has where you plug it in, and where it comes out. So we've got two nodes that represent it. We've got a node that represents a jumper going from the SFP to the patch panel. Patch panel has a front and back side. Off the back side it goes to a pigtail. Pigtail goes to a slice. So you can see the level of detail that we're putting in here. Most of you aren't doing this. That's the beauty of this model, is you can be as complex as you want. You can be as simple as you want. Because if I decide, hey, tracking pigtails isn't important, it simply isn't put in the model, or in what you deploy on that point. You wouldn't put a pigtail. You say, next, hey, you know, SFP app goes to the slice, whatever you want. I was talking to Eric, here's Eric, and I was giving him a little preview of this a couple of days ago, and he started to get excited because he wants to model sensing equipment on his network, right? So he deals with the campus, and their equipment, their fiber goes to doors, they go to alarms, they go to things that he wants to put sensors on, and that can easily be inserted into this. But what we're looking at here, for the purposes of the model, the trace model, is a typical feeder side, which consists of about 15 nodes, 2 point features, and 1 line feature. Okay. We move to the distribution side. Once you get to that splitter at the cabinet, you have the splitter out. You basically got 32 of these lines for every splitter, for every strand that comes into the splitter. 32 outs if you go 1 by 32. And we model the splitter, the jumper, the patch panel front, all the way out to the OLT port. So on this side, you got 12 nodes. You've got 3 point features, although you can consider this point feature part of the previous point feature called the FDH. You got 2 line features. Putting it all together, 1 FDH, 1 288 sized FDH or serving area would have 9 strands coming in, 288 strands going out. So roughly 1 serving area is going to be 3,591 nodes in this trace model that we use. It's a lot of data points, right? How long would that take in the utility? A couple of years, maybe, right? Connecting that up. You'd probably get to the point where, hey, we're not going to do this, 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 and this. We'll draw a line, we'll draw a point, and we'll do that. Okay, so all of that's great. So now we understand. We understood, okay, this is our trace model, this is what we're going after. Okay, user experience, let's bring that in now. How do we make this fast, right? Well, the general acceptance criteria for user experience has been studied quite a bit. Is we expect applications to launch in under 10 seconds. And after that, we start to lose focus, right? When you're in the application and you're doing something, most users feel like it's instantaneous if it's sub 1 second, right? I get an instantaneous response. Right? Google, I do a search, you can get 100,000 results back in 0.7 seconds. It feels good, right? You don't even think about it. That's kind of a goal that we're looking for, right? We want to get response times down to around a second, if not better. Generating a report, you could make the case that a trace is a report, right? We're getting a report. When users are trying to generate a report, you usually have their attention for up to 30 seconds before they start to lose, before they start to get frustrated. But even during those 30 seconds, you're going to have to do something to give them something to look at. That's why you see those little spinny icons and weedy flashing things that are going on. It's meant to kind of keep you engaged with that action that might take more than 5 seconds. You get to the 10-second spot, you don't have something grabbing their attention, you lose it, and you want to get that feedback while they're waiting. Now, there is a factor at the end, if there is some network latency or an understanding of network latency, people tend to kind of back off of these numbers, like, okay, we're doing it in the cloud, or this is web search. That is a factor, but it could also be a point of frustration. For those of you that play games, when you get that lag, you get pretty frustrated, right? So this is this guy who's waiting to get frustrated, right? Okay, so my question to you is, when you're performing a trace, what response time do you expect? Now, it's kind of a twofold, because we're all going to say, oh, I want to have things. But what have you been trained to expect now? What do you think you would feel comfortable with if you were performing a trace?
10 seconds. 10 seconds.
10 seconds, okay. That was kind of a baseline for us. I think initially when we started, we were looking at a lot of the crescent link, the real heavy traces. How can we get it under 10 seconds? That was a pretty natural point for us. People that were doing traces all day long, they wanted it much faster, 10 seconds. Anybody else have a different feeling on what their expectation is?
Before I release the click button.
Yeah, so 10 seconds, that seems pretty reasonable, right? Anything more than that, you might have some allowance for the size of the cable, things like that, what type of trace you're doing. If you're in the field in the rain and you're on a tablet, you want to get that thing really quick. So environment. We're going to get into the demo and show you what we've got. So we've done the data model, how quickly we are performing traces. But I want to set the stage. The demo, we're doing this from ArcGIS Pro 2.8.3. Running on SQL Server 2019 Developer Edition. This is basically Enterprise Edition. It is exactly Enterprise Edition without having to pay Enterprise Edition costs. It's designed for developers that are testing things out. We do have that deployed in a cloud environment. So today, what you're going to see is us hitting a cloud environment in North Virginia. We're running Enterprise. The features that we have on the map are feature services, so they're being delivered via that same via the cloud environment. We also have built the API gateway. So our perform trace is being sent back from an endpoint, the API endpoint, using AWS API gateway and then functions on the back end. And there's no utility network in any of this. Okay. A little more about the demo. I want you guys to. I got a comment on this? The database models 10,000 serving areas. So we built a small application to create a database that has 10,000 FDHs. Anybody dealing with serving areas that serve about 3 million customers? They laugh, but this is where our thinking was, right? It's like, how far can we push the envelope, right? Because you get a tier 1, that's pretty standard for them, right? Today, they'd have to have multiple databases for the regions because they couldn't handle it. We've got 2,800,000 endpoints in one database. 35 million individual nodes. The database size is 11 gigs, and the largest table is 3 gigs. So let that sit. Imagine the utility network. All right. It's all entirely cloud-based. All right, let's jump into the demo. All right, so we're going to start this off. What you're looking at here is, this is SQL Server Management Studio. For those of you that are familiar with DBAs and doing SQL queries, this is your typical client that you use to interact with the database. What we've done is we have a stored procedure on the database called perform trace. It takes an input node, so this is to simulate I am at this location and I am tracing the ONT port. This input node is a GUID, so that's how we uniquely identify this. So there's no object IDs, this is a GUID that is unique to this node and unique in the universe of this node. You already performed the trace?
Oh, it is.
Oh,
Not yet.
okay. So we're going to execute this. This is, if you're a developer, this might get excited about it. If you're not, just bear with us. We're trying to tell a story to get to the program. Okay. All right, let's go ahead and run it. It's executing the query. Look at that. Trace. This information, this is the information that the application needs in order to connect to features and display the trace. And it took 2 seconds. And that was a trace from an ONT, so we're representing 27 different lists, but these are all the individual nodes that were in that trace, from the ONT back to the source. Cloud trace. All right, now we're going to move into the next level. So we were hitting the database directly. You're saying, Jason, you hit the database directly. What's going to happen when you hit the API? Right, the API is another layer back from the database, so surely there's some overhead. So what you're looking at here is a tool called Postman. It's designed to let you interact with API endpoints. You basically give it the command. It gives you back a JSON string of the result that you just saw there. This result is then used by the application later. But this is an entry point, just like if you're troubleshooting a splice or troubleshooting a line. It's an entry point into our application to say, from the API, what are we seeing? Here we go. So from the API, we got 4 seconds on this one. That's a little bit slow. And we've noticed since we've been here with everybody on this network that that's what we're getting. So 4 seconds, not bad in a 35 million node database. I think if we run it again, we've seen it as fast as half a second. All right. We're still working out and tuning some things on the gateway. This is what we're expecting from the API, half a second on trace. Now we get into the meat of it. Here we have a map, 2 feature services. We've got points and lines, and what you're looking at here is, again, in the Clemson area, and we've modeled out a strand to a splitter to 32 different endpoints. Does all make sense? These endpoints represent where the ONTs, the jumpers, and the splices live. These lines represent the individual fiber strands. It's a little unorthodox. Normally you wouldn't draw each individual strand for a cable. But this is a performance trace tool. This is not an end user tool. Just know that. This is where the Crescent Link team and the stuff that they do, they can kind of piggyback on this. But this is a tool that Corey and I developed so that we could see how does doing a trace, are we getting back all the information that we need, so, and what performance are we seeing. So we're going to go ahead and pick that same ONT that he's up in here, got the Brightwire model over the trace performance tool. We're going to click this node, and you can see these were the nodes that we talked about on the diagram that were at that point. We're going to pick the ONT port. Now before he executes that, that's all right, that's great. You would expect, when you're on the distribution side, we believe users will expect that you're trying to trace back to the source, right? And so when we did that, that perform trace took half a second. Half a second. in total time, total round trip time, because there's a couple of other queries going on, connecting things to features, interacting with the map. We added about, about a tenth of a second to that operation. That's great. Now we're in the response time that we expect to be in, and we're at the client level, and we're in the cloud. Yay, right? All right. Next, so that's great if I'm tracing from the distribution side back, but what would you expect if you were on the feeder side? If I'm doing a trace from the feeder side, what might you expect to see? What might you expect to see?
All 32 of them.
Right, because if I had a cut on this line here, I would expect that if I did a trace, I want to know all the endpoints that are involved, right? So man, 32 traces, that might be expensive. Go ahead and do it. So we're going to pick the source, we're going to pick the OLT port, trace from it, all 32 endpoints. Slightly higher time, but not bad considering there's 35 million records. Okay. None of this is stored. This is all dynamically done. If you went in and changed your network, you get the same trace performance doing that. If you went to a line, anywhere in this network, that's what you can expect. This is the kind of stuff that we're putting in front of Ezra and saying, that's the performance we expect.
Jason,
We did it, you guys can do it too.
can you guys actually cause it to be slower? I don't want the university thinking I have time to do other things.
Yeah, we'll build in a little coefficient factor, and we'll vary it in the advanced operations. We're going to say, Tracy should take, let's put a 10 in front of that.
Put up a CY box that we're building for you.
No, that's a good point, right? And you know, Eric, he's being funny, but that's a real thing, right? When people start to see that, hey, my job just got quicker, my job just got easier, am I going to be replaced? You know, that's the kind of feedback we want to know, but you know, Eric, we're not going to make it slower. That would not be good. What? I know that this seems like a very simple demonstration, and I can see you guys are kind of absorbing it. This is a big deal to us. This is a really big deal. This shows that we can build a model using Pro, using an enterprise geodatabase, and get performance that should be expected in a modern application. And we're having real serious talks with Ezra about this technology. We're starting to ask questions like, well, how are you doing it? I could license it. That's a hope and dream. Our goal is to kind of get this closer and closer to you guys. We're still in the testing and tuning phase, and ecstatic that the demonstration worked. We expected it to, and you're always nervous when you're in our program. Any questions about this?
What's the timeline?
Great. Glad you asked that. Bruce, what's the timeline?
You haven't written about forward to that?
It was done yesterday. No, that's a great question, and it leads in, if I can, I want to go into the next slide and kind of talk about that, and then we'll expand on that. Any other questions about the demo specifically? Okay. So the road ahead. So what are we going to do with this, right? As Bruce said, we're kind of the back-end developers. We're building this model, we're building it out. We're developing the API functions to give to the developers to put a front end on. What you saw was just something we put together for performance tracing. But what we want to do is continue to expand the API functionality. We want to be able to do more things, simple functions like add nodes, delete nodes. The good news is we got the big elephant in the room with the trace out of the way, so everything else is going to be much simpler. We want to continue to evaluate the database. I was just telling you, when we started this, we started with 100 FDHs, and we did 1,000 FDHs. We said, let's do 10,000. I'd like to do 100. Let's get to something really big, something massive. We're going to keep testing this with larger and larger data sets, especially as you start to add attribute information into the database. What happens to it? So we want to make sure that we keep that performance baseline. We know what it should be. We want to make sure that we keep it. We want to be able to demonstrate this in a native client and web app. last week. Like, can we get the JavaScript out quickly so we can show that? But I decided against that, but again, this is part of being able to access this information in multiple places. And the other important point which came up in the last segment was being able to transition the Crescent Link data model to this. We gotta have a little bit of that. So to answer your question, when is it coming? I would say sometime next year, mid-year next year, you should see more and more things as this migrates into our products, as we find a good inflection point to kind of cut over all of this to our products. But keep checking with us, right? And things like when we're at a conference, like IMGIS is coming up, not sure, pseudo-virtual, pseudo-in-person, we're not sure what's going on with that. But as these conferences keep going, keep checking with us. Our goal as the research and development team is to keep pushing this story and narrative forward. So when you ask me in 3 months, when, we can have a better answer. I wish I could tell you it was today. I know sitting in your spot, and I've been there, it might feel like smoke and mirrors because you're saying, hey, you're showing me this in the test environment. But I assure you, having been a user, we are not showing you smoke and mirrors. We are showing you the real deal, and this is what we're showing. Sorry, I can't be a little more precise. Do keep checking with us. As you have information and thoughts too, please reach out to us. Let the support team know, call in, or contact us directly. We'd be happy to have more discussions, especially about your needs and the different types of networks that you need. Eric and I are going to spend some time talking about how to manage sensors and how to plug in. That's going to grow our database. So maybe we'll get to 100,000 of these sensors. All right, any other questions?
I'm assuming that this is gonna be once you're on Pro. I mean, as we're just gonna drop desktop and actually do away with it, and like I said, it's kind of a moving target.
Yeah.
This is only gonna go into the Pro versions for future.
So this is going to be agnostic for Pro. So I don't think we would build we'd have to discuss it. I don't think we would build a desktop version that interacts with this model unless there's a need. If you guys say, hey, we're not moving to Pro, we know there's a 5-year window, but we're not going to Pro, then absolutely we're going to build a client that takes advantage of this on desktop. If
And I
there's a
think
market
that's
need for it, we're going to.
where it's gonna be important to see what can be done with Pro.
Yes, yeah, and you know, there are a lot of opportunities at play for us here. I am kind of joking about Esri talking to us about this technology. That would be exciting if they did want to license this technology from us. At the same time, we'd be worried that we'd be giving a competitive advantage to all the other Esri partners, right? So it's just kind of, what do we do? So, but Bruce and I, especially, we're engineers in the telco business, and we are doing this. This whole team is doing this because we have a passion for it. And so, we're not going to leave you guys. Question? So I want to thank you. I heard a lot of stories at the reception about the things that you guys are doing as users. Maybe a little sentimental thinking about the problems that I had to deal with as a planner and as an outside plant engineer, dealing with those things. Please keep us informed. If you ever have a reason to call or reach out to us, we'll love to talk shop, get your feedback. We'll do a better job, even though we're kind of in the basement, the back of the building, and we're the quiet part, not the front customer-facing side of things. We still do really important, and I really want to appreciate your feedback. So thank you.
All right, we've got about 5 minutes till our next